The task didn't seem that hard. We were just gonna make some fresh pasta. What we got was a whole lot more complicated. I don't even know where to begin. The control system doesn't make any sense. The storage drawer is a nightmare to close. The dough doesn't mix. The noodles are stuck together by the time they reach the plate. It takes an hour to clean, and oh yeah, it caught on fire.
Our group decided to go with a kitchen appliance because we have a common interest in cooking. After looking at different products of this type, we decided to do a redesign on the Gourmet GPM 100. The pasta maker had numerous interior subsystems, as well as a suitable level of complexity. Had several poor reviews on Amazon and was within our budget.
Due to poor quality, the motor failed on the 8th use. Replacing the motor is out of our budget and would not provide any interesting design opportunities, so we opted out of including it in our redesign.
To disassemble the machine, you first remove the extruder nut. Then pop the bonnet. Remove the extrusion screw and the extrusion chamber. Remove the screws on the rear casing. Remove the rear cover. Now we can see the internal components of the pasta maker. These include an AC motor, control board, and switches.
The pasta maker can be divided into 3 major subsystems: the mixing and extruding system, the control system, and the pasta grid and storage system. The mixing and extruder system contains an extruder screw, an extruder chamber, a mixing shaft, and a mixing chamber. The controls include a circuit board and an overly complex set of switches. The machine also came with 6 pasta grids for extruding spaghetti, linguine, vermicelli, rigatoni, fettuccine, and penne. It also included 2 measuring cups that don't match the provided recipes.
The disassembly gives us insight into how each component contributes to the overall function of the machine. A signal is imported to the machine via switches on the top. The control board identifies whether the mix or extrude setting is selected and spins the motor clockwise or counterclockwise, respectively. A mixing shaft uses long tangs to mix raw ingredients. Switching the direction of rotation forces the dough into the extrusion chamber, where a screw extruder forces the dough through a pasta grid to produce the desired noodles.
We reached out to potential customers ranging from those who had been making fresh pasta for years to one who had never tried fresh pasta in his life. We had them complete the entire pasta making process, starting with removing the pasta grid and selecting a new shape out of the storage drawer. Then adding the ingredients, mixing the dough, extruding the dough, cooking the pasta, tasting the pasta alongside some dried pasta we prepared, finally cleaning the machine. Here's some of the feedback we received.
I think the control system is redundant and not very intuitive. It looks like a toy. This machine makes the worst noodles in the world. They all stuck together and they were really dry.
No matter if I floured the noodles constantly, I would still get noodles that would stick together and make gross pasta.
The controls are confusing and the bottom drawer is hard to locate. Looks like it's cheaply made. I don't like it.
By consolidating our customer feedback, we decided that we needed to remove one of the switches because the redundancy confuses new users. Switches were simply bridged together, so we needed to rewire the controls to the main power switch. We had 2 options for how to tackle the storage drawer: widening it to increase the storage space, or eliminating it to allow for new functional designs. We found the best option to be removing the drawer and mounting the pasta grids on the back. We also decided to change the vibrant green to a less off-putting blue to improve the visual appeal. Because the most common functional issue our customers ran into was the noodles sticking immediately after extrusion, noodle adhesion became our primary redesign goal. We found that the extrusion process forces the moisture to the surface of each noodle, and the direction of extrusion causes the noodles to touch almost immediately. After working through many stages of concept design, we ultimately concluded that there are two ways to guarantee the noodles don't stick. The first is to add a stand onto which the machine is rotated, so the noodles extrude downward. The second is to blow hot air from the motor over the noodles to dry their surfaces before they make contact. We designed these concepts in such a way that they could work simultaneously.
The low-resolution prototype visually represents our redesigned concepts. By using 3 foam boards, we were able to produce the prototype for only $3. It demonstrates the concept of rotating the pasta maker 90 degrees on its stand. This causes individual noodles to separate under their own weight. It also shows how a duct could be used to blow air onto the noodles to evaporate surface moisture, thus preventing adhesion.
We purchased acrylic boards from the makerspace. Fortunately, the acrylic was the exact size we needed. We drilled 4 holes in the acrylic, 2 holes along the back edge and 2 holes along the bottom edge. Taking a threaded rod, we cut it into 4 pieces that were 200mm long. We also used a belt sander to round the corners. We inserted the threaded rods into the holes of the acrylic and tightened the nuts. Our stand was complete. Holes were drilled in the casing of the machine so that bolts could be put through to be used as supports. To create the air vent, we started with sheet metal. We cut a piece and bent it into a square tube. We took a second square tube and attached it to the first tube at a 50-degree angle. We attached a fan to the ducts. We attached the fan duct system to the pasta machine. To test how well the redesign prevented noodle adhesion, we extruded dough in the following 4 variations as part of a 2 factorial experimental design. The standard orientation, in the 90-degree position, with the fan on, and in the 90-degree position with the fan on. We recorded the percentage of noodles stuck together and how many clumps were formed. We then tested the level of adhesion by lightly pressing 10 noodles from each variation onto a wall and recorded how many stuck out of 10.
We found that by extruding the noodles in the standard orientation, 100% of the noodles stuck together in 2 groups. Nearly all the noodles stuck to the wall and remained there until they hardened. The noodles extruded in the rotated position did not stick to each other while extruding. But when they reached the plate, they became inseparable. Because of this, we were unable to conduct the wall test. The noodles extruded in the horizontal position with the fan blowing formed 7 small clusters of noodles and 14 individual strands. The noodles at the top of the extruder stuck together because the air only reached the noodles at the bottom. Regardless, only one of the noodles stuck to the wall. The variant with the noodles extruded in the rotated position with the fan blowing worked flawlessly. None of the noodles stuck together or to the wall. The combination of surface drying the noodles and preventing them from touching during extrusion proves to be the ideal variant.
After seeing the success of the redesign, we took it to the next level by extruding the pasta directly into boiling water. The noodles looked great, and they tasted pretty good too. All in all, we managed to improve our customer satisfaction by repurposing the storage drawer for airflow, developing a stand, simplifying the control system, and changing the color scheme. The total cost for the redesign was only $17, which makes it a practical addition for the commercial device, and our customers loved the new look, improved functionality, and the copious amounts of free pasta. Thanks for watching.